So now let's dive into some descriptives. And if I just want to look at the mean BMI over facility, then I can just use the t-apply command. And when I see these means, it looks like facility C 36.7 versus 24.9, 24.6. There's a difference. So I'm expecting that we probably have we have statistical significance for BMI across facility. Let's run this as well for sex. The means across sex, the BMI for males is 31.9 versus 26. So there does seem to be, a difference there. Is it statistically significant or not? We don't know yet. We have to analyze the model. But I think what's most important here would be able to look at the interaction, the means in the interaction of facility across sex. And I can do that by using the aggregate function. And I want my Y, which is BMI, across. So what do I have? Facility plus sex. And I want my function to be equal to mean. Now this is, I'm about ready to sneeze. By the way, I tested positive for COVID this morning, which is just a bummer, but obviously I feel kind of decent. Or I wouldn't be doing this, but okay, sneeze is gone. All right, so what this allows us to do is it allows us to go in and look at the cell counts. And I look at the cell counts here. This 40.1 just jumps out at me. Males from facility C seem to have a BMI. It's kind of out of whack with the rest of them. This 33 is a little concerning. Females in facility C, but I don't know how that's going to impact. I don't know if the 33 is far enough away from 27, 26, 21, and 23. And again, that's why we run the analysis, okay? So I would probably go ahead and just do a summary of the model. And again, just so you don't think I'm just doing some sort of voodoo statistics, I'm accessing this model I created way back here to test the assumptions. And let's see what happens. Now remember, I have tunnel vision. When I first run my two-way ANOVA with interaction, I have tunnel vision on the interaction effect. And facility cross-sex is statistically significant at the 0.001 level. So I'm going to kind of ignore facility and sex as main effects. This has got all my attention right now. This is telling me that one of those cell means, at least one of those cell means, is different than the other one. And based on the descriptive statistics I have back here, I'm betting that this is going to play a role. Now, bring in something that's kind of a bummer in a way. We have to, okay, let me just type it here. The AOV command expects a balanced design. All right, now R will let us run the AOV command when we don't have a balanced design. We typically don't have, or we definitely don't have a balanced design because I have more males than I have females, and I have more patients from facility A than I do B and C. Balanced design would mean that all of my cell counts, my lengths in there, would be the same. And I think that you can actually, I think we can actually go up to aggregate. For some reason, I'm not even sure this works, but Yeah, it does work. So for a balanced design, we would need all of these numbers to be the same. We would need the same sample size in each of the cells across the interaction, and we don't have that. So we don't have a balanced design. So we have to make a correction here. And the correction is we have to download something called the car package. No, wait a minute. We've already used the car package, right? Did we use that? Yeah, okay, so it's already there. But I'll tell you what, I know that students jump around, and I just want the library card just to let you know that you have to have it before implementing this new command. So the new command is called an ANOVA command. And the ANOVA command is just ANOVA with a capital A, and it uses the result from the AOV that we created way back here. And again, I called that model. So I want to apply the ANOVA on my previously calculated ANOVA, but I need to do what's called a type 3 ANOVA calculation. Now, as a user of statistics, don't worry about what that means. Just understand that you have to do that. And I don't think it's going to make a big difference here anyway because we're not that unbalanced. But we have to make this correction in the presence of an unbalanced design. So let stat geeks like me worry about that. You just know that you have to report that if this was going in a journal article. So we end up getting 4 components, or I should say we get a decomposition of 4 components. Again, we get the main effect for facility, we get the main effect for sex, and we get the interaction effect for, sorry, I'm comparing the values up here. The sum of squares and things, are different, aren't they? 45. Okay, anyway, I'm sorry. I'm just curious about this. And then we get the unexplained, the residual component. What I want you at your level to understand is that we have 2 main effects and 1 interaction effect. So our focus is on the interaction of facility across sex. And as you would expect, if we connected at all with a one-way ANOVA, with the two-way ANOVA, it's the same thing. If we have statistical significance, we need to run a post hoc. So I'm going to run a Tukey HSD on my model, but I need to identify the facility over sex. I think that's right. Yeah. So what that's going to allow me to do is it's going to allow me to do a whole lot of pairwise comparisons. And you can see now that the reason that we actually rejected the null for the interaction is we have a lot of pairwise comparisons that are different. For hospital or facility C, females are different than females from facility A. So any of these down here, in fact, the only 2 that aren't statistically significant pairwise are females from facilities A and B and males from facilities A and B. All the rest of these have difference in BMIs across facility and sex. Now, it's nice to get a an interaction plot that takes a look at the means of the interactions, and that's also really easy to do. I can just use the with command, and I can create what's called an interaction plot. And this is a little different because I put facility, I put my first two categorical variables and create my interaction plot this way. Now, this allows me to compare a lot of things. It allows me to compare the mean BMI from facility A to B. You can see that much difference. The facility from B, the mean difference in BMI across the solid line is male and the dashed line is female. And you can see that the difference in over facility C for male and female as well. So typically when you have, if you have this interaction plot, I think we might actually be better. This is something you have to play around with a little bit. I always change these around just to see what the plot looks like. And anyway, if we have intersecting lines, then the interaction will almost always be statistically significant. So we have intersecting lines there. We can see that for female, this is facility A. This looks like it's facility B and C. We can see the differences here, and then across gender we can see the differences as well. This contributes to the interaction being statistically significant. All right, gang, I hope I haven't blown your mind too much. Next thing I'll do is demonstrate how to run these in StatCrunch, and we'll go from there. All right, take care.